Have you ever wondered where the Avogadro constant came from? Why this random number? The first time I heard it, I also felt a bit confused. So in this video, I'm going to explain to you its significance and why scientists have chose this number. So in this video, I'm going to tell you why this number. Second thing is, why do we need to use moles to measure the amount of different substances? And three, I'm going to go through two example calculations for you to see how theory comes into play in a more realistic context. And what type of things does scientists want to measure the amount of? Well, they can be atoms, which is the smallest unit of matter, and ions, which are a type of atoms but with a charge. Number of protons is more than or less than the number of electrons, because protons have a +1 charge and electrons have a -1 charge. And so by comparing the number of protons and electrons, then we're able to determine the overall charge, which wouldn't be neutral for ions. And molecules are two or more atoms chemically, keyword chemically, bonded with each other. And scientists are interested in measuring the amounts of these different types of matter that commonly come up in a laboratory context. And so let me first introduce the idea of moles. So moles is about measuring the amount of something. And the reason why you have to invent mole in the first place is because, let's say you have a sample of a substance in a lab. However, each single atom is very, very small, and it's impossible to measure the amount of the substance using atoms as a unit, because there are just simply too many. And so therefore, we made this new unit where 1 mole equals to 6.02 times 10 to the power 23 number of particles. Well, particles can be both atoms, as I mentioned just now, but also molecules or ions. And to understand this, I shall explain the definition of particles. Particles is the smallest unit that behaves independently. Keyword independently. So the reason why molecules are also part of particles is because the atoms are chemically bonded together. Therefore, during a chemical reaction, or how they just behave in nature, they undergo the chemical reaction together. The atoms are already bonded to each other. They don't behave differently. They behave as one single entity. And so therefore, it is considered as a particle. And because we are measuring, let's say we have a sample of molecules, let's say water, for instance, it doesn't make sense to split up the atoms and split up the hydrogen atoms, split up the oxygen atoms, and calculate them separately. It doesn't make any sense, because we're trying to calculate the amount of water, and since one water molecule behaves as one entity, therefore we consider one particle as one water molecule. And so whenever we're calculating the amount of water, we never split the atoms up. That is a really common mistake to make at this level. And so by defining 1 mole as this many particles, we're able to calculate a smaller number when we calculate the amount of the substance, and therefore we are able to use this number better, or enable us to make calculations that we're able to do, and also makes calculations more convenient. And so if we look at these examples, atoms versus molecules, this exactly represents what I said just now, where they are, although on the right hand side shown here, there are more atoms than the left-hand side. However, the number of particles is the same because particles is an independently behaving unit, smallest unit. And so since in nature, within a ammonia molecule, in this case, on the right-hand side, the atoms within the molecule don't split up. They act as one single entity during reactions and how it behaves. And therefore, one ammonia molecule is one ammonia particle. The mole equation is mole equal to mass over relative atomic mass or relative molecular mass. And we use atomic mass if we're calculating atoms or ions, and we use molecular mass if we're calculating molecules. And so before explaining this, I should explain a little about how the Avogadros constant arise and why is it such a specific number that scientists have chosen. So scientists have realized that carbon-12 has a mass of 12 kg when it has an amount of 6.02 times 10 to the power 23 number of particles. What's so special about this situation is the relative atomic mass shown here, carbon-12, where there are 6 protons and 6 neutrons, and electrons have negligible mass, and protons and neutrons are weights the same. We consider as a relative mass of 1 and 1. In this situation, in the specific amount of carbon-12 atoms, there are 12 grams of it. And so the relative atomic mass, which we represent as AR, equals to mass, which we can represent as M. And so at this specific amount of a substance, the relative atomic mass equals the mass of a substance. And therefore, when there's 1 mole of a specific substance, then we can consider its relative atomic mass as the mass of the substance in grams when there is 1 mole of it. And so this allows us to, because by measuring the weight of, measuring the mass of a substance is relatively easy. We just put it on a balance in a laboratory, then we're able to get a value. And if we know the relative atomic mass of the substance, then we're able to get the number of moles of a substance by using the mole equation. And we know that when there's 1 mole of a substance, the mass and the relative atomic mass equals to each other. And so in that case, mole will be 1. And when either the mass changes or the relative atomic mass changes, it changes sort of the ratio. And by using this equation and plugging in the numbers, we're able to calculate moles. And so let's try to put this mole equation into practice. So for calculation 1, it asks us to calculate the mass of calcium, and we know that there are 0.5 moles of calcium. So if we use the mole equation from just now, which is mole equal mass over AR, we know that there's 0.5 moles of calcium and we're trying to find the mass of it. And we know the AR of calcium is 40. Since scientists designed mole in a way that is so convenient, where at that specific amount, the mass of a substance equals to the relative atomic mass of a substance, meaning that the relative atomic mass represents the mass in grams of a substance when there's 1 mole of a substance, and therefore now we know that there are only half a mole of calcium, and therefore mass must be 20, even though we know from this equation that it's 20. But if we think about it logically, because there's only half a mole and the relative atomic mass represents the mass of a substance when at 1 mole, because it equals each other, as we discussed earlier, we know there's only half of the amounts now, and therefore it'll be 40 divided by 2, which is 20. So mass would equal to 20 grams. Let's move on to calculation 2, which involves a molecule. And remember, a molecule, you consider one molecule as one particle, because that is the smallest unit it can get, where the unit behaves behaves independently. And so if we calculate the moles of ammonia, so let's get out the mole equation. Mole equal to mass over MR in this case, because we're thinking about molecules. And so we don't know the MR of molecules, the MR of ammonia, sorry. There's no information about that in the question. However, we're able to derive it from the periodic table. And so what's the chemical equation of ammonia? It is NH3. And we know that the AR of nitrogen is 14. And we know that the AR of hydrogen is 1. And so it will be 3 times 1 because of 3 hydrogen atoms. And therefore, the MR of ammonia would be 17. And so if we want to calculate the moles present, then we shall compare the number, the numerical number of the mass present and also the MR. And so we know that there are 27 grams of ammonia, and we know there are 17, the MR of ammonia is 17. And we know that at 1 mole of ammonia, the MR would equal the mass of ammonia. However, the mass of ammonia is greater than the MR of ammonia. That means that the amount must be larger than 1 mole. And so that is sort of, we think from first principles. However, from first principles, we derive the mole equation. And now if we use the mole equation, we get this mole equal to 27 over 17. And if we just put it into the calculator, be 1.59 moles of ammonia. So I hope this video has clarified your understanding of moles. Perhaps made you think that chemistry is less memorization, and there are reasons behind these constants that seem random, but they're actually not. Please give any feedback you have in the comment section below, and see you in the next video.